you're asked to use Leibniz rule to evaluate the integral I of alpha is equal to the integral from 0 to 1 of x to the alpha minus 1 over ln x dx, where I of 0 is equal to 0. Okay, now this type of problem, it follows a similar pattern. That's how we'll work it out here. Alright? Now, Leibniz rule. Leibniz, not Leibniz, apostrophe s. It says that when you differentiate, you find the derivative with respect to alpha of the integral from a to b of a function of x and alpha dx, right? The integral is with respect to x, but the derivative is with respect to alpha. This is equal to, so now what you do is differentiate under the integral sign. Is the integral from a to b of the partial derivative of partial alpha of f of x alpha dx. Alright? Now, you might see Leibniz rule written elsewhere in different format. You might see it as the derivative with respect to x of integral from a to b of f of x and t dt is equal to the integral from a to b of the partial derivative with respect to x of f of x and t dt. You might see it that way. Now I'm using alpha and x because that's what we get. We get ln x and we get alpha, alright? The important thing to note here is that the derivative is with respect to x, right? While the integral is with respect to t. In this case up here, the derivative is with respect to alpha, right? While the integral is with respect to x. And you go from total derivative with respect to alpha to, when you go under the integral sign, it's the partial derivative with respect to alpha. Okay. So, let's see what happens in this case. Now, what we have here is I of alpha, right, is equal to the integral from 0 to 1 of x to the alpha minus 1 over ln x dx. We don't have a derivative here. What we have is an integral alone. So where does the derivative come from? Alright, what we have is an integral. If you have the integral of a function, what do you do to go back to the function? You have to differentiate the function. Alright? So we are going to differentiate I of alpha, right? Now, here, if we differentiate I of alpha, we can we can call it I prime of alpha then. So to differentiate, we're going to differentiate with respect to alpha, of course. So we find the derivative with respect to alpha, the derivative of something with respect to alpha, which is the derivative of I with respect to alpha, which we will call I prime. Now what is it? Well, if we did differentiate here, we differentiate here. So we differentiate both sides, right? So let's rewrite this thing first. So we say I is equal to the integral from 0 to 1 of x to the alpha minus 1 over ln x dx. We find the derivative with respect to alpha of I of alpha. We differentiate I of alpha, right? We have to differentiate both sides. So we differentiate this of alpha. So we're finding the derivative with respect to alpha of the integral from 0 to 1 of x to the alpha minus 1 over ln x dx. Now we're going to do what Leibniz rule says we should do. Alright? But alright, we keep this as it is. So the derivative with respect to alpha of I of alpha is equal to, now we say integral from 0 to 1 of, now we go under the integral sign, it's going to be the partial derivative, right, by partial alpha of, now here is going to be x to the alpha minus 1 over ln x dx. Okay, so we have that. Now here, let's concentrate on the derivative alone for now. Just the derivative. Let's put a bracket around here, even though we don't need it, just to emphasize that we're doing what is in the bracket first. We'll wait until later to carry out the integral. Now, it means that we are differentiating with respect to alpha. Partially, partial derivative with respect to alpha. So we treat x as if it is a constant for now. So let us take this. This is equal to the integral from 0 to 1 of, let's treat x for now as if it is a constant. Right? Alright. I know the bracket is there, but I don't want to crowd the screen too much. This is going to be, what we have is, in this case here now, the integral from 0 to 1 of, this is going to be the partial with respect to alpha of x to the alpha minus 1 times 1 over ln x, and then later on we do the integral with respect to x, right? I just shift this from under here to separate it, but I'm going to put it here. Alright, let me do it under. I'm going to put it back as the integral from 0 to 1 of, let's put it at the front, of 1 over ln x times the partial derivative, partial by partial alpha of x to the alpha minus 1. We're going to differentiate with, we're going to integrate with respect to x dx. Alright? Do you see that? Now, here, we're going to concentrate on this part. Now, let's go inside the bracket, inside this bracket, and differentiate them one by one. So we write back the integral from 0 to 1 of 1 over ln x. Alright. Inside this bracket, we have the partial by partial alpha of x to the alpha minus the partial by partial alpha of 1. Alright. And later on we differentiate with respect to x. Now, you see this thing here? It kind of look like when you're integrating a to the x. Now, you are integrating x to the alpha. If you're not integrating. Why I say integrating? It's differentiating. If you say y equal a to the x, what is dy by dx? Right? When you differentiate that with respect to x, it would be, remember what it was? Then what you'd have is a to the x ln a. Right? You remember that? So, in this case, you have the integral from 0 to 1 of 1 over ln x time the derivative. Now remember, you're differentiating with respect to alpha, just like how you're differentiating this with respect to x. Alpha is in the power. It's something raised to the alpha. This is something raised to the x. So it's a similar argument. But in this case, a would be like the x. So it's going to be x to the alpha ln alpha. A to the x. Oh, a to the x ln a. My mistake. It's going to be a to the x ln a. Yeah. So this would be a to the alpha ln x. Right. So y equal a to the x. dy by dx is a to the x ln a. Ln this a. So differentiating with respect to alpha is going to be x to the alpha ln x. This. Alright? Alright. Minus. When you differentiate one with respect to alpha, what do you get? It's 0. Alright? Dx. Okay. Now remember, this isn't a part of the working, it's really rough work. Alright? Alright, I'll just erase it. Just make a note of it. Erase it from now. So remember, when you have y equal a to the x, then dy by dx is a to the x ln a. Alright, so what happens after this? So what we have here, the derivative with respect to alpha of I of alpha, derivative with respect to alpha of I of alpha, I of alpha is equal to this, right? Is equal to the integral of, let's put this together now, from 0 to 1 of 1 over ln x, which is this, right? Times this part now, x to the alpha ln x dx. But then ln x cancel ln x, right? ln x into ln x goes one time, ln x into ln x goes one time. So what you have is the integral from 0 to 1 of x to the alpha dx. Okay, good. Now that you're integrating that, what you have when you integrate this is x to the power of alpha, add 1 to the whole power to get a new power, and divide by the new power, right? And you're going from 0 to 1. So what you have, the upper boundary, x to the alpha plus 1, you substitute for x, you substitute 1 for x, 1 to the alpha plus 1, right, over alpha plus 1, right, minus the lower boundary, 0 to the alpha plus 1 over alpha plus 1. Okay? That is equal to, well, in this case, this part will be 0. Because 0 to any power is 0, and 0 over anything is 0. So this is equal to 1 to the any power is 1. So it's 1 over alpha plus 1. See that? So here, the derivative by d by d alpha of I of alpha is equal to 1 over alpha plus 1. But then you want to go back from the derivative of alpha, of I of alpha. You want to go back from the derivative of I of alpha to just I of alpha. You want to remove the derivative. So what you have to do is integrate. So you integrate to remove the d by d alpha. So to do that now, if you integrate d by d alpha of I of alpha, you integrate 1, you integrate both sides, right? You have to integrate both sides. Integrate 1 over alpha plus 1 with respect to alpha, because you have to integrate with respect to alpha. Oh, I have to write the d alpha on this side too. So integrate this d alpha is equal to integrate this d alpha. Alright? Now, if you integrate this with respect to alpha, you integrate 1 over alpha plus 1, the alpha. What we can do, alright, let's work it out. We have the integral of 1 over alpha plus 1, the alpha. Now, let u be equal to alpha plus 1. Right? Now, du, we're doing integration by substitution. Du by the alpha is equal to 1. Right? So, when you multiply both sides by the alpha, du is equal to 1 times the alpha. Now, we run out of scrolling space, you know. So here now, if we integrate this, we have integral of 1 over u, the alpha. But the alpha is the same as du. So we want a function of u du. So we integrate 1 over u du. This would be equal to what? You remember, when you integrate 1 over x dx, you get ln x. When you integrate 1 over u du, you get ln u. Alright? So now, if you want to put it back or in the original format, you would get this being equal to ln. So in that case, you have ln alpha plus 1 plus c, right? You have to remember these basic rules of integration, so you can remember them when you're working these things out. So going back to this now, what you have. Alright, let's draw a line. We run out of scrolling space, so let's draw a line up and continue and working on the other side of the line. Alright, so here we have the integral of d by d alpha. Let me just rewrite it. The integral of d by d alpha of I of alpha is equal to integral of 1 over alpha plus 1 d alpha. The integral of 1 over alpha plus 1 d alpha and then we worked out a while ago that the integral of 1 over alpha plus 1 d alpha is actually ln alpha plus 1 plus c is equal to ln alpha plus 1 plus c. Alright? So you see that. Now we want to know what c is. What is c? Well, the question had said I of 0 is 0. So here at the start you had 0, right? That implies that c is 0 because when alpha is 0, ln 0 plus 1 plus c is equal to ln 1 plus c. 0 plus 1 is 1, right? So ln 1 plus c. What is ln 1? If you use your calculator to find the natural logarithm of 1, you get 0. So it's 0 plus c. And the question said that, this question says that I of 0 is 0. So the integral when alpha is 0 is 0. So 0 plus c is 0. So therefore c must be 0. Alright? See that? So in that case, c is equal to 0. So what do you have? Here, remember, I find the integral of the derivative of I of alpha. The integral and derivative is like they cancel out each other, leaving I of alpha alone. Right? So c is 0, so you can just write ln alpha plus 1. So it's ln alpha plus 1 there. Right? So that is what we get as our answer. So we can say, therefore, the integral from 0 to 1 of x to the alpha, the integral from 0 to 1 of x to the alpha minus 1 over ln x, just to check and make sure that's what it says, x to the alpha minus 1 over ln x dx is equal to ln of alpha plus 1.